Hello everyone, welcome to Comp 3821-9801, Extended Algorithm Design and Analysis. My name's Raveen, and I'm joined here by course admin.
I'm Sal.
And Gerald, who is, I guess, the brains of the operation.
Yeah. So I guess we'll talk about sort of the big picture of why you would want to study extended algorithms. So I guess the overall big picture of the entire course is to really set you on a path towards research and towards really appreciating the underlying complexities of modern algorithms, right? So a lot of problems in the real world can actually be modeled as abstract problems, and what we want to do is to essentially bring all of that into the course and to really show you that lots of these problems that are hard or that are easy are actually problems that we know how to solve. We just need to teach you the tools behind it. And that's essentially what the Extended Algorithms course is really trying to teach you.
Yeah, so the objectives that we have in mind for the Extended Algorithms course are, as with the regular algorithms course, that you're able to understand algorithm techniques, solve problems, and communicate about them. But also that you're able to link that to real-world problems and have an appreciation of what is out there in the field of study that is algorithms and modern research that's going on.
So the course follows directly from Comp 2521 or Comp 9024, which is data structures and algorithms. We use those as our building blocks here. We've also introduced a new prereq this term, which is Math 1081, discrete math, or Comp 9020, which is Foundations of Computer Science. There we go. Which probably shouldn't be an issue.
Yeah, those new prereqs are there to make sure that you have some foundation in how to write arguments, how to reason about algorithms and related ideas, but also some of the graphs, number theory, and counting techniques that are used throughout algorithms.
So speaking of outcomes, I guess sort of the primary goals of this course is to really get you to understand how to properly prove the correctness of algorithms. So maybe you have some sort of algorithm that you've conducted for a problem and you want to show someone that it's actually correct. Well, we will teach you how to actually formally prove that what you've done is actually correct, or we'll show you how to actually find counterexamples to your algorithm as well, which is just as important as actually proving the correctness of your algorithm. So on top of proving correctness, we'll also teach you how to properly write out or how to write out a proper algorithm and how to communicate that to your peers who might not be as versed as you are in the algorithm world. And we will also teach you some basic LaTeX techniques that you would basically require if you decide to go into research and if you want to do a thesis in the end.
So, how are we assessing you on these ideas? I think one of the pieces of feedback that we've heard previously is that extended algorithms, you know when you're doing this course that you've signed up for a challenge, but even so it's a little bit intense. There's a lot of moving parts, a lot of frequent deadlines, as some will attest to, and there's occasionally been a little too much going on. So we wanted to pare that back and give you more frequent and more short loop kind of feedback, but while also giving you a little bit more guidance to do your assessment tasks. So where previously we had assignments every 2 weeks or so on an individual basis, this is replaced by a portfolio of small tasks. Those tasks can range from anything, can be anything from do a multiple choice quiz on rare occasions, all the way up to solve an entire problem in a similar style to an assignment task. However, the main differences here are we are very happy to help you get to that answer, and we're not interested in marking and giving you a number out of 20 for how good your submission is, but rather we want to either designate this task as done or tell you this is what's wrong with it, go and fix it. And we feel that in this way we're helping you along the way as you're still learning, and only at the end of the course when you've had the opportunity to internalize all this, do we give you an exam where you are genuinely on your own? Yeah. So the portfolio will be conducted as a series of formative tasks, which are run on Jake's platform, Formative, and in each of those tasks, you will get feedback from one of your lab demonstrators. You'll get to iterate on that until it's done without any penalties or anything like this. So you'll have several of these tasks a week, and the higher grade you want to achieve in this course, the more of these tasks you have to do. So every task has an associated grade, and you only have to do the tasks up to the grade that you're aiming for. In extended algorithms, there will be relatively few pass and credit tasks just to ensure that you have the fundamentals down, and we will focus more on the higher end where we'll give you interesting problems, but also give you the help along the way to get those problems out and really appreciate why they're difficult and how we can attack them.
Project and exam?
Oh yeah, project. So the portfolio is 50% of your grade. The final exam is 35% of your grade. We do require you to get a mark of, I think, 40% on the final exam, just to show us that yes, you can do things on your own. Because where the portfolio tasks you can work with your friends, that's totally fine as long as you submit something that's basically your own work. The exam is when we can really test you in isolation, which leaves 15%. Of the assessment, and Gerald's going to talk about this because this is fun and exciting. Sure.
So on top of all of the assessments that we have, we also have introduced a project, which is a group-based assessment where you get to work in groups of 2 to 4, basically on anything that you want that is tangentially algorithmic related. So this is deliberately open-ended, just so that you sort of have your own freedom to sort of get into the feel of what it's like to do algorithm research. And if you don't want to do research, if you don't plan on doing research, that's totally fine as well. We also give you the option to do anything that's creative or anything that is educational as well. So you also have the option to do something that's not necessarily research-based, but something that you want to maybe implement, or maybe you want to write about something that's creative or write about something that's educational that you can show off to your friends, your family, industry mentors, or even academic supervisors as well.
So, on top of all the assessment this term, how are we going to help you along the way? Excellent question. We are going to continue with tutorials that...
Can I jump in for a sec? Because there is one other thing, which is lectures. So in the past, this course has had a flipped classroom structure that we'd have recorded videos, you'd watch those, and then you'd show up to lectures where we'd do problem solving in person. We're not going to be running that this time. We're going to do traditional lectures instead, where we deliver the lecture during the lecture time, and reinforcement of that will happen in tutorials. Go.
So tutorials, tutors will go through selected problems each week, walk you through how to solve them, what the underlying ideas are. That's a pretty standard 1-hour tutorial. And then you will also have a 2-hour lab slot. In this 2-hour slot, you're welcome to work on your formative tasks. You're welcome to present or show them to the demonstrators of the lab and get feedback on them. They'll help mark tasks off as done, or they'll tell you where you need to improve on. On top of this, we'll be running the Ed Forum once again, where we have dedicated forum moderators checking through it so you can ask whatever questions you have about the course. In fact, it's probably going to be where you get the fastest answers because the course email will be flooded.
I'll also mention here that your project group can be anyone. It doesn't have to be people within your own tutorial or lab group, and so there will be dedicated times for project mentoring. So we'll have a couple of staff who are running kind of drop-in sessions where you can talk about your project, get some ideas, get some guidance on how you're doing, what else you could look into, and they come from a variety of backgrounds, so we'll have some information about the different people who are helping you with projects and who you might want to go to. What was next? Modules, great.
So the modules of this course is going to be essentially similar to the regular course as well. So you're going to have your foundations which is going to be really, really short because we assume that you have enough of the background material to want to basically do this course. So we'll basically jump straight into divide and conquer, which is essentially an algorithmic paradigm that breaks down a problem into smaller parts. Each of these parts are then broken down into smaller parts until the part can't be broken down anymore, which is then trivially solved. Then we move on to greedy. So greedy is an algorithmic paradigm that essentially says every time you make the local best choice, you build your solution up to the global best choice, whatever that happens to be. And then the greedy heuristic ends up being very simple. So a lot of the times, every time you have a greedy algorithm, generally it is a very simple algorithm. It's very simple to implement, and it's very easy to describe. However, you'll see that not every problem can be solved with a greedy algorithm, and we will show you that actually, even though greedy might not give you the best solution every time, it doesn't actually do too badly in most cases. And we'll actually provide some examples of where greedy might actually be a good heuristic to have, even if it's not optimal in every instance. If you don't have greedy, then we'll jump straight into things like flow network, which is where you can model a problem abstractly as a network, and then we'll teach you many different algorithms that actually solve the standard flow network problem. And then we'll have dynamic programming, which is similar to divide and conquer in that you split your problem into multiple parts, but each of these parts are actually overlapping. So what ends up happening is you actually save quite a bit of time just by computing something once and then storing it into some sort of array or some sort of table, and then you can just do a constant time lookup for these. And then we'll look to the last module, which is essentially I guess you can kind of say the reason why we even study these techniques in the first place, and that's to really look at the hard problems or intractable problems. And so the running theme throughout the entire course is really on how we can relate two problems that seemingly have nothing to do with each other, and how we can actually show that these two are actually really the same problem in disguise. And this is essentially what we do in the entire course. We'll look at different problems that look really different to each other, and it will show actually these two problems are one and the same thing if you just frame the problem in a slightly different way.
Now, you may have already inferred this, but we expect a higher caliber of student to take extended algorithms, and that's kind of what you're signing up for by picking extended algorithms. The assessment structure of 3.821 is very similar to 3.121, and because of that, there's actually a larger window of opportunity for students to switch between the two courses. I believe we're happy until the end of week 2 at the very least.
For sure, until the end of week 2, no questions asked, and then
Probably.
up until census state,
Yes.
you'll need an okay from us, which we will always give you. So if you are in doubt as to whether you should do Comp 3121 or Comp 3821 or the equivalent postgrad courses, we generally recommend that you give extended a go for a while, see how you're doing, and reevaluate. Again, the bottom line is that regular algorithm, shall we say, is a good enough endpoint for your study in algorithms. It's everything you need to know. But if you have interest in studying further into theoretical computer science, if you have interest in doing research, if you just want the intellectual challenge, we really encourage you to give extended algorithms a go. It's a great course. You're going to learn a lot, and you're going to meet other great students who are passionate and motivated like you. Yeah. So we look forward to you bringing your enthusiasm to extended algorithms this term, and we'll see you around.